Hi, this is CAD/CAM Lessons. In this part of the FreeCAD series, I'll show you why parametric CAD is so powerful, because every step is saved in the feature tree, and you can edit it anytime. We'll focus on the most useful sketcher constraints, so your sketches stay stable even when you change dimensions. Okay, we have this simple model, and by the way, I will show you one of the huge advantages of FreeCAD and other parametric 3D CAD systems. What we do in these systems is build a model based on features and parameters, and during the creation of the 3D model, every step is saved in the operation tree. We have the operation tree here. At this moment we have one operation, but if there were more operations they would appear here. The point here is that while creating a 3D model, we have access to the operation history all the time. We can go back to previous operations and make changes there. If you now wanted to make changes to this solid, for example, you wanted to change the height of this solid, you can simply edit the pad operation. To do this, double-click the left mouse button on this operation, and here you can enter a new value, for example 30 millimeters. Click OK, and the changes have been applied to the solid. Similarly, you can also edit the sketch based on which the pad operation was created. To do this, expand the pad operation. Here we have the sketch based on which this solid was created. To edit the sketch, double-click the left mouse button, and we can change the dimensions here. For example, I will change this dimension from 120 to 150 millimeters. And notice what happened. This dimension has been changed, but at this moment, the circle no longer lies in the center of this rectangle. We will come back to this in a moment. But now we close the sketch, and as you can see, the changes have been introduced to the solid. Now let's return to editing this sketch. This circle currently no longer lies in the center of this rectangle because the position of this circle was strictly fixed, and this circle lay in the center of the rectangle only in one specific case, where the lengths of the rectangle sides are 150 and 70 millimeters. If I now change, for example, this dimension to 90, this circle no longer lies in the center in any axis of the rectangle. Now, for this circle to lie in the center of the rectangle, we need to edit the position of the circle's center, and we do this by editing the dimensions. Here we enter 75. Here we enter 45. And now this circle lies in the center of the rectangle again. But if I now change this dimension from 150 to 100 millimeters, well, we have a problem again, and this circle does not lie in the center of the rectangle. In such cases, we can become somewhat independent of dimensions by using geometric constraints. If, like in this case, for example, you want this circle to always lie in the center of the rectangle, it is better to use geometric constraints here, not dimensional constraints. Dimensional constraints define one fixed, specific position. We define a specific distance between geometries, but as you can see, cases may arise where a dimension might be changed. Then it is better to apply relations between geometries and specify that a point, for example, should lie between 2 points, and this should be done independently of the geometry dimensions. I will show you how to do this on this example. First, I will remove the dimensions defining the position of the circle center. Here, we can apply a symmetry constraint between points. I click the left mouse button outside the geometries to make sure all geometries are deselected. I select this point, and select this point, and choose the symmetry constraint. Now this circle lies in the center of this rectangle, and will always lie in the center of the rectangle, regardless of what the dimensions of the rectangle sides are. We close the sketch, and the changes have been introduced to the solid, and this circle will always lie in the center of the rectangle. I go to edit the sketch, and here we just applied a geometric constraint. We assigned a relation between geometries, and this relation specifies that the center of this circle lies between the corners of the rectangle. This is one of the basic relations. Applying such relations in some cases will allow you to become independent of the model's dimensions. If in the future you need to change some dimension of the model, you just need to change the dimension you care about. And as in this case, the position of this circle will always be in the center of the rectangle. Another basic constraint is the coincidence constraint. This constraint specifies that 2 points lie in the same place, or a point lies on a line. In this case, we place the corner of the rectangle at a specific distance from the origin of the coordinate system, but we can do it so that the corner of the rectangle lies exactly at the origin of the coordinate system. To do this, I will remove these dimensions. At this moment, the position of the rectangle is not defined, but notice that the position of the circle is already strictly linked to the rectangle. These geometries are linked to each other. Simply the position of the rectangle is not defined relative to the origin of the coordinate system. We can do this in such a way that we place this corner of the rectangle at the origin of the coordinate system. To do this, we select this corner, we select the origin of the coordinate system and choose the coincidence constraint. Now the sketch is fully constrained, we close the sketch and we have a solid created based on this sketch. In a moment we will move on to the next simple example, but on this solid I want to show you the basic issues with adding fillets and chamfers. If you want to add a chamfer or a fillet, you can do it based on an edge or based on a face. You can do it in such a way that first, with the control key, you select the edges to be chamfered or filleted. You can select one or more edges and choose the operation. In this case, I selected the fillet operation and here we specify the radius value. We click OK, and in this way, we can add fillets. By the way, I will also tell you about navigation. If you want to rotate the model, press the mouse wheel and simply move the mouse. If you want to zoom in or out of the model, we do it using the mouse wheel. We simply rotate the mouse wheel. If you want to pan the model, press the left and right mouse buttons simultaneously, and you can move the model. Okay, I will now proceed to adding chamfers. With the control key, I select two edges, choose the chamfer operation, and here I specify the chamfer dimension. I click OK. In this way, we can add chamfers and fillets. We can also do it such that we first select the operation and then indicate the edges to be chamfered or filleted. I will remove the chamfer operation. I select this operation, click the right button, and select delete, or simply press the delete key on the keyboard. On a Mac, we do this using backspace. And now, like this, I select the fillet operation, and here I indicate the edges I want to fillet. Now, if we select the operation first here, we have the advantage that we can indicate edges simply by clicking the left mouse button on the edges. We don't have to hold a key. Here we specify the radius dimension. Click OK. If you want to edit this operation and, for example, want to add more edges to be filleted, simply go to edit the operation, click the select button, and you can indicate subsequent edges to be filleted. Click confirm selection. OK. And another edge has been added, and if you want to remove an edge from the fillet, go to edit this operation. Double-click the left mouse button, now select the select button, and we can indicate the edge on the model again, and this edge will be removed and will not be filleted. We can also remove it from the edge list. Simply click on this element in the edge list, and this element will be highlighted on the model. Press delete or backspace, and the edge has been removed and will not be filleted. The chamfer operation works similarly. We can also select this operation first and indicate the edges to be chamfered. Only here in this case, I think we first need to select the select button, and now we can indicate edges to be chamfered. I don't know why the select button had to be pressed first. In the case of filleting, we could indicate edges automatically, and these edges were added to the fillet. In the case of chamfering, we first click the select button and indicate the edges we want to chamfer. Regarding the chamfering and filleting operations, this operation also works based on a face. We can fillet or chamfer all edges of a selected face. We indicate the face, select the operation, specify the chamfer or radius dimension, click OK, and all edges of the selected face are chamfered or filleted. Regarding saving files, we do this as standard from the File menu. We select Save As and specify the file name and location. Similarly, if we want to open a previously saved model, from the File menu we select Open and indicate the location and name of the file we want to open. This works as standard, just like in other programs. I will now move on to creating another project. I close this project without saving changes and create a new parametric part. Here, just like before, we will start by creating a sketch on the XY plane. Here we will practice the symmetry constraint a bit. We will start by drawing a rectangle, but this time we will choose the center rectangle command. That is, it is a command that allows drawing a rectangle such that first we define the center point of the rectangle, and then we define the position of the rectangle corner. Select this command regarding the center point of the rectangle. We will place this point at the origin of the coordinate system. If you hover the cursor over the origin of the coordinate system, this point will be highlighted, and a coincidence constraint symbol will appear next to the cursor. This means that if we click the left mouse button here now, the center point of the rectangle will be automatically constrained to the origin of the coordinate system. An automatic coincidence constraint will be applied here, linking the rectangle's center point with the coordinate system's origin point. Now, while drawing the rectangle, we can specify the dimensions of this rectangle. Here type 120 millimeters in the x-axis, press enter, and in the y-axis type 100 millimeters and press enter. I click the right mouse button to cancel the rectangle drawing command. Now the rectangle is fully constrained, fully described, the dimensions of the rectangle are specified, and the position of the rectangle is also defined. Here an automatic constraint was applied. In most cases, automatic constraints work well and are very useful, but sometimes situations can arise, especially when there is a lot of geometry close to each other, where we might accidentally apply a constraint we didn't intend. This will of course become more understandable to you if you start creating more complex projects in FreeCAD, but if you would like to disable automatic constraints, you can do it here. Expand these options, and here you have the options for auto constraints and auto remove redundant constraints. Sometimes these options might not work correctly, and sometimes your sketch might turn orange. An orange sketch usually means that this sketch is over-constrained. This sometimes results from the fact that during geometry creation, automatic constraints were applied, but not all redundant constraints were removed, or if you add constraints yourself, there are too many of them, and the sketch is over-constrained. This information also appears here, and there is also information about which constraints are redundant, and then usually it is enough to remove these constraints from the constraint list. Now I will try to do something like this. You don't have to do this. I just want to show you what this is about. I select Draw Circle and will draw a circle anywhere, for example, with a diameter of 30 millimeters. I click the right mouse button, and now I will turn off the removal of redundant constraints. Okay, so I select the center of the circle, select this line, and choose the coincidence constraint. Now I will place this circle between these 2 points. I select 2 corners of the rectangle, select the center of the circle, and choose the symmetry constraint. And here the information appeared that we have a redundant constraint, and the redundant constraint is constraint 14. In this case, the redundant constraint is the coincidence constraint I applied to place the center of the circle on this line. This constraint is redundant because by applying the symmetry constraint between the rectangle corners, we automatically place the circle center on a line lying between these corners. So this constraint in this case is a superfluous constraint. Now, if something like this appears for you, don't panic. In this case, it is enough to remove the redundant constraint. I click the right mouse button, select Delete, and now the center of the circle has been automatically placed between these 2 corners of the rectangle, and the symmetry constraint also ensures that the center of the circle lies on this line. Now I will press Ctrl Z to go back to that moment. I turn on the option to remove redundant constraints and will do the same thing I did before. I add the coincidence constraint here, and now I add the symmetry constraint. In this case, FreeCAD automatically removed the redundant constraint. So when creating geometry in FreeCAD, you will very likely encounter the sketch changing color to orange, and the first reflex of many beginners is slight panic and slight consternation. But you don't need to panic. Just pay attention to what is written in this place, whether there are redundant constraints. At this moment, I will remove this circle, and now we will practice constraints a bit. I select Draw Circle, and I will draw the first circle more or less in this spot. We will make a circle with a diameter of, for example, 15 millimeters. Okay, and I will draw the second circle in such a way that the center of the circle lies on the x-axis. I hover over the x-axis. The x-axis is highlighted, and a coincidence constraint symbol appears next to the cursor. As you can notice, in this case, a coincidence symbol appears that binds a point to a line. If I hover over a point, a coincidence constraint symbol appears that binds a point to a point. It is one and the same constraint, it just has different symbols. If we want to constrain a point to a point, something like an X appears, and if we want to constrain a point to a line, a point lying on an arc appears. In this case, we happen to want to apply this constraint. We want to constrain the center of the circle to the X-axis, and I want to do it automatically. Therefore, I hover over the X-axis. When the X-axis is highlighted and this symbol appears, I click the left mouse button and draw a circle of any diameter. I click the right mouse button to cancel the circle drawing command, and I have a drawn circle whose center is constrained to the x-axis. I can change the circle diameter because I did not specify the circle diameter while drawing this circle, and I can change the position of the circle center, but I can only change the position of the circle center along the x-axis. We can also apply such a coincidence constraint manually, as you have already seen. We simply select the point, select the line, and choose the coincidence constraint, or simply press the C key on the keyboard. If you hover over the command, a tooltip window appears, and some commands have keyboard shortcuts, and in this case, the coincidence constraint is the C key. I press the C key, and the circle's center point has been constrained to the x-axis. In this case, I would like to apply a symmetry constraint between the centers of these circles so that they lie symmetrically relative to the y-axis. In this case, instead of applying a coincidence constraint, I can apply a symmetry constraint right away. I select this point, select the y-axis, and choose the symmetry constraint. The symmetry constraint is the S key. I press the S key, and here this point automatically jumped onto this line. Simply, the symmetry constraint specifies that these 2 points lie symmetrically relative to the y-axis, which also means that this point will lie on the x-axis. Now, if I change the position of one circle, the position of the other circle also changes so that symmetry relative to the axis of symmetry is maintained. In this case, the axis of symmetry is the y-axis. And another thing is I would like these circles to have the same diameter. I can, of course, select this circle, choose dimensioning. Dimensioning is the D key. I press the D key, define the dimension position, and type 15 millimeters. And now the diameters of these circles are the same, but if I now want to change the circle diameter from 15 millimeters to 20 millimeters, I have to change the diameter of 2 circles. In the case of 2 geometries, it is not difficult, it is not time-consuming. We can do it easily, but if there were more of these geometries, if, for example, we had 20 circles of the same diameter, and later it turned out that we need to change the diameter of all circles, then it is pointless to click on each circle and enter a new value. We can apply a relation here that specifies that the dimensions of the geometry are equal. I will remove the diameter dimension of this circle, and to do this, to specify that the dimensions of these circles are equal, I select these 2 circles and choose the equality constraint. The equality constraint is the E key. We can click this icon, but we can also click the E key on the keyboard. Now, the diameters of these circles are equal. If I now change the diameter of this circle, the diameter of this circle will also be changed. I will return to the value of 15 millimeters here, and the circle diameter has also been changed. Here, what you might notice is we have 1 degree of freedom. You can click on this, and the geometries where some relation, some dimension is missing will be highlighted here. Before you add a dimension or relation, I suggest clicking the left mouse button outside the geometries to deselect all geometries. Sometimes after clicking in this place to highlight degrees of freedom, not everything might be clear. That is why I often simply drag some geometry gently to see where I can move this geometry. In this case, a dimension is missing. In this case, a dimension is missing defining the position of these circle center points either relative to each other, or relative to other geometry, or relative to the origin of the coordinate system. And here we will do it such that we define the distance between the centers of these circles. I select the center points of these circles, press the D key on the keyboard, and here I enter 70 millimeters as the distance between the circle centers. And the sketch is fully constrained. The sketch is green, and now we can no longer freely change the shape and position of these geometries. I click the right mouse button to cancel dimensioning. Now we will proceed to creating more geometries. We will draw more circles. I will draw a circle more or less in this spot, and I will draw a circle more or less in this spot. I intentionally do not specify the diameter of the circles. I click the right mouse button, and now we will apply the equality constraint. I select these 3 circles and choose the equality constraint. And now these newly created circles also have a diameter of 15 millimeters. Regarding the symmetry constraint, we can also apply the symmetry constraint between a point, and so I would like to place these circles we created a moment ago symmetrically relative to the origin of the coordinate system. To do this, first we select the geometries we want to place symmetrically, and finally we select the geometry that is to be the symmetry geometry, and we select the symmetry constraint. Now it works such that these points are arranged symmetrically relative to the origin of the coordinate system. Here, of course, we can change the position of these circles quite freely, but they are arranged relative to the origin of the coordinate system all the time. And to remove the degrees of freedom, we need to define the position of one circle. In this case, we can do it by defining the distance of the circle's center point from the rectangle corner. I select these 2 points, press the D key, and here in the x-axis I enter 15 millimeters, and I will do the same in the y-axis. I also enter 15 millimeters as the distance between these points. I click the right mouse button, and even though I defined the position of only one circle, thanks to the fact that we had the symmetry constraint applied, the position of the second circle was also fully defined. And, okay, not to complicate this example any further, I think this will be enough for us at this moment. We close the sketch, and based on this sketch, we can create a solid of a specific height. We click OK, and we have another solid based on a sketch. Here, the goal of this example was mainly to work a bit with the sketch, because the sketch is the basis for creating a 3D model, and we can create a 3D model in stages, and later in the course we will get to that. But for now, I want to focus on such basics, which in my opinion are very important. And by learning these basics, learning the basics of creating sketches, issues related to dimensioning, constraints, we are able to avoid many frustrating moments that can appear in the beginnings of learning 3D modeling. Now you know how to edit features in the tree and how to use symmetry, coincidence, and equality to keep sketches robust and predictable. To see the next step, click the video on the screen or subscribe and continue the full series in the playlist.